Hi, DD Solar here. So I wanted to crank out an extra video, but not a super long one. And this is a relatively simple project. So let me show you what I'm doing. On my solar workshop, I have a door area that is really dark, and the only lighting I have would go out if the power goes out. So in order to prevent that from being an issue, I have this light here. This particular one is made out of metal. It's all metal, all aluminum, cast aluminum housing. That's glass. And I tend to really favor lights that are made out of metal because the plastic ones just get so brittle and they're so unreliable. This one is user serviceable. It has screws instead of glue. You can take these screws out, you can access the battery, you can access the LEDs, the wiring, anything you want to do. One concern would be this here. This is just a switch to turn it on and off. This is just cheap plastic. So there is a potential issue there, but you really just make sure this isn't exposed to the sun and the UV radiation. You should be fine. The grommet here, I mean, really just make sure it's not mounted upside down with water traveling up the cable. One of the main problems you have with a cable like this is if you mount it up and the water is coming down, it will run down the cable and it will sit on this grommet. So that's a trick to keep in mind. Kind of try to mount your wires going down, and that will prevent that problem in most cases. Next part of the puzzle is I need to mount a rather strange little solar panel on the side of the building. It's a steel building. And of course this starts to look a lot like an excuse to play with magnets and solar panels, two of my favorite topics. Now here we can see the specs on this solar panel. This is a really small solar panel, 3 watts, 6 volts. And I'm not complaining, but it comes in a plastic frame, which I'll zoom out and show you. The camera will focus. And the plastic frame is kind of, it's a cost-cutting measure. And I'm not going to complain. This is a real solar panel. It's glass. The construction is exactly the same. And I started seeing these show up on eBay a while back and other sites. You can see it's real glass. It's built exactly like a normal solar panel. Got the epoxy on the back. The only difference is it has no metal frame. Instead, they give you this plastic one. I'm willing to accept that for the price I paid, you're going to get a plastic frame, and that's probably going to become more and more common as the time goes on due to inflation and everything else. What I want to do is mount this solar panel securely on my steel metal building, and I really don't want to make some kind of bracket and have it sticking out the top. And this is plastic, and I don't want to do too much to stress it or to put too many holes in it. So magnets would be an ideal solution. And if you've seen my last video, I like to play with magnets, and I was experimenting with mounting solar panels with magnets. Now this is a much smaller solar panel. I don't know, it weighs a pound, something like that. It's pretty small. For this experiment, I purchased these magnets, got them on Amazon. The other magnets I had were just a little too big and heavy duty. This magnet is rubber coated. It's very strong. And it has a female thread on the magnet. And it has I believe these are M3. I'm actually not sure what size these are. Sorry, these are M4. Yeah, these are M4 threaded metric screws. And these are a little easier to deal with than M6. M6 is just overkill. Comes with a bag of hardware. So my plan was to use 2 or more of these powerful magnets. Actually, they're a group of magnets. And use this to mount the solar panel directly on the side of my metal building. With the power of these magnets and the lightweight of the solar panel, there is no way, I don't think there's any way this would blow off this side of the building. If there was a hurricane, I would probably remove it, but I don't think it's a problem. What I intend to do is wall mount the solar panel. Now I've had some success wall mounting solar panels. They still work. You lose output, but not as much as you would think. It really depends on where the panels are facing, not so much whether they're on a wall. Of course, I am on the east coast of the United States, so that may matter. It does matter where you are geographically in the world, but in my case, it really doesn't affect me that much. I can mount solar panels on the wall, and I don't lose enough power that it discourages me from doing so. I want to mount the solar panel right there, or right there. There's not a lot of options here because these ribs that are formed in the paneling and used to add strength, they're kind of in the way. I also bought this cool little camera light, which is on my workbench here, and I'm trying to use that to increase the quality of the footage. I found out I didn't have enough lighting. So really, it's just a giant experiment. Not an expert, just playing around, trying to see what works. Now that I have these holes in the plastic frame, which by the way is a little tougher than it looks. This frame is not super durable, but it is not as cheap and rinky-dink as you would think. I'm just going to enlarge these holes a little bit. They're a little on the small side. For that I'm going to use my step bit. And you got to be a little careful with a step bit in plastic, because the step bit can catch the plastic and rip it out of your hand, and it can also crack and splinter the plastic. But like I said, this plastic is good enough for the purpose. Now I'm simply going to mount these magnets on the back, but with some standoff, because I want the solar panel to stand out a little bit from the metal building. So to get some standoff, I need some spacers. I have these 25mm M4 machine screws. They're a little longer than I want, and I could always swap them out later, but I'm going to go ahead and use the 25mm M5s or M4s that I have. Instead of using spacers, I decided to use these M4 machine nuts, which I had left over. I don't know why I got them. I just so happened to have them available. This will give me about 22mm of standoff, 21mm, I'm not really sure. That might be 5mm too much. I can always order some different machine screws. This solar panel is going to be tucked in to the metal trim and have a shadow on the panel if I don't add some standoff. I also don't want to allow the wind to come in and get behind the panel, so I'm not really sure exactly how many millimeters of clearance I need. Right now I'm only attaching 2 magnets. That will allow me to get a feel for what's going on here. And this little tiny panel is not going anywhere, but I may add a 3rd magnet later. I think 4 would be absurd. I don't intend to add 4. I think that would just be ridiculous. Now that the M4 machine screw and machine nut are there, I can just take the magnet, which has a female M4 thread, which is quite shallow by the way, and put that on there. And if I was smart, I'd use some Loctite or something, but right now I'm just testing the setup. So I'm not going to fence myself in too much. Yeah, they go in there pretty good. Yeah, that's pretty good. I think this will stick on the building quite well. I can put a 3rd here if I wanted. These magnets are rubber coated, and the idea there is you don't want them to rust. Neodymium magnets tend to corrode. I guess in theory with this rubber they shouldn't corrode, but we'll see about that. Now what I can do is take this frame and place it over the solar panel. And this big wad of wires here, I don't want to shorten them. That's the way it is. I'm going to find somewhere to hide them. I'd rather have too much wire than not enough. Now this should just snap right on. And it's got a lot of clips on there, and it's quite satisfying how it snaps in, so I don't think that will be a problem, the security of it. Okay, so there's the magnetic solar panel. This is really light. If I like how things turn out and I feel like I need more magnets, I have a spot right there. That should work fine. Okay, this is what I would call the light head. This has the batteries and it has the LEDs and the electronics in it. This is a different story. This thing, I don't know exactly what it weighs, but all I can say is if this fell and hit me in the head, I would not be happy. Having something heavy like this mounted on a building with magnets is definitely a liability. However, I want to experiment with magnets, and I'm going to give it a try. Most likely, I will mount this with a self-tapping screw. However, I have some magnets, and I want to try them. These are the ones with the M6 thread. These are really beefy magnets. Here are the other magnets. These are very similar, but they have M6 thread, so much larger. They look pretty beefy. And I'm going to start with 2 of these on the mounting bracket because that's all that will fit. Now here's a little trick about mounting things with magnets. Magnets have a pull force. Problem here is when you have a bracket like this, you don't want to put it in a position where it will cause leverage. You don't want to have leverage on the magnets, because if you do, the magnets will be vulnerable to being popped right off the side of the building. What you want to do is you want to mount this so that it's pulling on the magnet, so that the weight of the device you're hanging is pulling. Anything that will torque this way and that way is simply going to pop those magnets right off, or at least they are much more vulnerable to being popped off that way. Pulling them off, yeah, that's pretty hard. It would take a lot more than the weight of this solar light, so I'm not worried about that. However, to test the magnet, I'm going to mount it near the ground where I can reach it, because I'm still experimenting with this. I don't think a raccoon or an animal is going to jump up and climb on the light. None of those things will happen. The way I'm going to mitigate the safety issue is I'm not going to have this very high up off the ground. That way, if it does fall, it's not going to hurt anybody. If you put this 12 feet in the air and it falls and hits someone, you're in trouble. So never do that. So I'm going to do this experiment on the ground, under safe conditions, try out my light, try out these magnets, and see how they perform, and then I'll move on from there. And here I'll use my good old standby neoprene rubber. I use it for everything. And I'm simply going to put a hole in there, and I'm going to use this to make me a little spacer. And this will help push the magnet a little bit farther away from the bracket. The mounting studs interfere with the mounting bracket on the light. So I'm just buying myself a little bit of extra space and sort of isolating the magnet from the metal bracket. And I do not have the proper socket set for these nuts here. They're very hard to turn, and they have nylon in them to prevent them from working loose, which I can appreciate. So I'm going to try to use my impact driver here to get things started, and then I'll have to do the rest probably with a wrench. We'll see what happens. I got to get some deep sockets. And thanks to the rubber, that's making it a little bit easier. Yeah, that was pretty easy. So there's the mounting setup. This particular light has a hidden feature. You can actually take the back off and flip it around 180 degrees. I am not going to do that right now because I'm not sure exactly where the light will end up living. Right now I'm going to keep it close to the ground and do my experiment and see how I like the light, how the lighting pattern is, and see how long it runs and how it charges and things like that before I mount it way high up where I need a ladder to get to it. Be careful not to strip that. And just like that, there's the completed mechanism. Now the way you want to mount this light is like this, so that the weight of the light is balanced and pulling down on the magnets. That is the safest way to mount the light, and it needs to be up against a building, hopefully within close proximity. But for my experiment, I'm going to put it near the ground. And these magnets, I tell you what, we're going to see how strong they are. No, I don't recommend mounting the light this way, but you don't learn until you try. So we're going to try it and learn. I'm not going to learn in such a way that will endanger people from heavy metal objects falling off my building. But anyway, so I need to connect the solar panel, and it has this nice little weatherproof connection. I won't call it waterproof, but it's weatherproof. Now these have an O-ring, or a seal. You can see that black strip running around. Normally I put a little bit of Vaseline on those, just to help them seal. And you could use grease. It doesn't really matter. And this is actually a 2.1 millimeter plug-in socket. This type of connector is really common on garden lights, solar lights. Once you tighten it, it's a good idea to pull it and make sure it doesn't move, because if it moves, it's not properly tightened. Some of these are incredibly hard to tighten by hand, and you have to resort to using a wrench. But this one's fine. It's not budging, so that's sealed up tight. I still would not mount in such a way to allow water to funnel down inside. I wouldn't mount it like this. If it's going to be getting wet, I'd want it to be like this, so that the water will have a good chance of leaving the plug and not creeping its way in. Now there's nothing left to do but to go outside and slap this onto the side of the building and see how it turns out. Okay, it's time to see if this is a bad idea or not. So I got my panel here with 2 magnets, not 3. I'll need to protect this wire junction here. And I got the magnets pretty clean. The metal is, it's not perfectly clean, but I'll just wipe it with my hand. And I'll have to tuck the magnets under this trim here. And you can see there's some standoff. And that's necessary because this trim really protrudes and it would shade the solar panel. And it's also a bit bent out. So let's go ahead and try this. Yeah, that's on there. That's not going anywhere. In fact, I think it would break the panel if I'm not careful. With a third magnet, I don't see any way that's going to go anywhere, especially with the trim sort of protecting the edges. I hope you can hear me over the air conditioner running. So here's my magnetic light head. Let's go ahead and give it a try. It's actually bending the metal paneling on the building. This is more than good enough for a test. That isn't going anywhere. And the bounce is coming actually from the metal panel that is actually bending. It's actually moving. I can see it moving around. I think that will be good enough for a test. Now you might be wondering, what do I do with all of this extra wire? Well, it's very simple. Just bundle it up nice and neat. You just stuff it in behind the trim. There you go. Which is basically some built-in wire hider. I think it's professional enough for a scientific lab test. I forgot, I need to test the light. There really is very little solar right now. It's basically not going to charge today. So I'm not too worried about it. I'll probably turn it off for the night. Yep, comes right on. So there's a switch on the bottom that allows me to turn it off. And I'll go ahead and hit that because this light is not fully charged and never really charged at all. So I want to give it a good chance, and I want to give it a full day's charge before I test it. Hope you enjoyed this short video about my magnetic solar light project. I hope to have some other more detailed videos coming in the next few weeks. Thanks for watching, and I'll see you later.